In this presentation, I'll be explaining the standalone and grid-connected photovoltaic system. Let us see what do you mean by the standalone type of PV system as well as grid-connected type of PV system. Now, coming to a photovoltaic power system is standalone type, in which standalone type used in a remote area with no access to the utility, where no grid is not available, utility grid is not available. It's a type of standalone type can be used, in which here the PV panel is and that power is used to charge the battery, and the battery output is using an inverter converted into AC, and that is given to the AC load. Therefore, this is a system of a standalone type, in which PV system, there's a energy storing battery is there, there's a DC to AC converter, inverter is there, so that is given to the AC load. Therefore, these are used where there is no access to the utility. Continuing the photovoltaic power system standalone type. In standalone type solar system, the solar panels are not connected to the grid, but they are used to charge the batteries. Therefore, rather than connecting this solar system into the grid, that is used to charge the batteries. And these batteries stores the power produced by the panel, and then it is converted by using an inverter, DC to AC inverter that is converted into AC and given to the AC load. And standalone type of solar power system have been used for a long time in areas where there is no public grid availability, or it's not the grid is not available. We'll be using the standalone type. Now the standalone systems are much more expensive than the grid connected system, because we have to use the batteries. This battery is the recurring cost is for the cost of the battery is also includes, therefore it is more expensive than grid connected system. The standalone type is more expensive. That is because of the batteries. Now let us see different configuration or connection of the solar PV system standalone type. In this one, 4 types being explained. Here PV panels are there, that is connected to the DC load. This is the unregulated one. There is no regulation depending upon the solar installation. The output power as well as voltage will be changing. There's no regulation is there. Therefore, it's an unregulated system with a DC load, the first one. And in order to make its regulation, we'll be connecting a converter. In between this one, we'll be connecting a converter, DC to DC converter. Plus, in order to track the maximum power, there's a maximum power point tracking system also there. Therefore, controller is also there. Therefore, between the DC load and this PV panel, we'll be introducing a block which the purpose of which is that to control the voltage, to regulate the voltage, as well as to track the maximum power. Therefore, DC to DC converter plus controller, maximum power point tracking controller is there. That is in between the PV panels as well as DC load. This is called a regulated system with a DC load. And let us see the third case is that in order to increase the reliability, we are adding one more battery here. Therefore, source is there. Battery is the PV panel is the, and there are 2 sources. And of course, again, same as this one, it's a DC to DC converter plus maximum power point tracking controller. Therefore, that output is given to a DC load. Therefore, this is a regulated system, PV system with a battery and DC load. And the fourth case is that same as this one more thing is added, that is there's an inverter is added, that is DC to AC converter, that is given to AC load. Because a regulated one, DC regulated one with a controller is there, PV panels, and there's a battery is there. And apart from that one, there is a inverter is there. The output of inverter is connected to AC load. So system can supply both AC load as well as DC load. There's a battery is there. Of course, there's a controller is there. Of course, DC to DC converter, maybe boost converter or a buck boost converter is there. So these are the 4 type of configuration of a standalone type of system. Again, coming to the standalone type of PV system, as I already explained, a PV panel is there. It's an unregulated one. Depending upon the solar insolation or irradiation, the power as well as voltage will be changing. There's no regulation. It's not regulation. That is given to the DC load. It's an unregulated system with a DC load. The second case that, as I already explained, there's a converter is added in between PV panel as well as DC load. Of course, there's a maximum power point tracking system is also there, so that in a PV curve, it can track the maximum power it can extract at this one. Maximum power can be extracted, and that can be given to the DC load. Therefore, this is a regulated system with a DC load. The third case is that here a PV panel is there, DC load is there, converter is there with a maximum power point tracking charger is there, and in order to increase the reliability, we are adding one more source. Battery is also added, so that if there is absence of the solar radiations, that will be supplied by the battery, or the reliability of the system can be enhanced by adding one more source, battery as this one. Therefore, that is given to a DC load. Therefore, this is a regulated one also. So, a regulated system with a battery and DC load. And one more case is that fourth case, as I already explained, that PV panel is there, DC load is there, of course, DC to DC converter, either buck boost converter or a buck boost converter, and one more source battery is added here, like same thing here. The one more addition is that there is a inverter is there, that inverter converts the DC voltage into AC, and that is given to the AC load. So for this system, again, it's a standalone type, and that is a regulated system with battery and AC and DC load that can supply both DC load as well as AC load. Therefore, it can track the maximum power, that is maximum power point tracking system is there, as well as it can convert into DC as well and AC, or it can supply the DC load and AC load. Another type of PV system is a hybrid, it's called the hybrid. In that one, in order to increase the reliability, apart from the PV panel, we'll be adding the other sources like diesel generator, battery, like that. If you are adding more sources, and that is controlled by a power conditioning system or controller is there, that will be controlling, or that is basically it is there will be a DC to DC converter, and finally it is a DC to AC converter, so inverter is there. All those comes under this block, that is power conditioning and control unit, maximum power point tracking, etc. is there. Therefore, here there will be three sources as such: diesel generator, battery, and there's a PV panel, and that is supplied to either AC load or a DC load. And here it is more reliable as such, because more sources are added, therefore it is more reliable. That is a hybrid type of photovoltaic power system. The third one is that photovoltaic PV system is a grid connected one. It's a grid connected one. This can be small system with such as a residential roof type, or a large grid connected system. It can be done. Just as a pictorial, it is represented. There is a PV panel is there. There is a existing grid is there. In between, there is a power conditioning. There will be a controller, DC to DC converter, controller, and DC to AC inverter. Everything will be in this block, and finally you will be getting that is AC signal that is connected to the grid. So grid connected system, or DC power, or that power that is available in the solar panel can be injected into the grid, existing grid. That's called grid connected system. Reliability and the efficiency of the system can be enhanced by connecting the sources to the AC grid. Therefore, we are connecting the DC source, which is energy, or that power, that into the grid by converting that into AC, and that's connected to the grid. Or this basically is a grid connected system of PV system, a solar panel. Continuing the photovoltaic power system grid connected type. Here, as I already explained, there's a grid is a 3-phase 3-wire system grid is there. The source is there, maybe solar panel, some DC source is there. In between, there is a inverter is there that converts DC to AC, and that is connected to the grid through a linking inductors, LA, LB, LC. 3-phase system is there. So 3-phase voltage that is here, and here there is a DC voltage, and there's an inverter. And in this case, if you are injecting a current which is in phase to the grid voltage, the power flow will be from DC source into the AC grid. In that case, the inverter will be working as, this also converter can be working as an inverter. The power flow is from the DC source into the AC grid. Now, if you make the injected current by controlling this converter, if you make the injected current 180 degree out of phase the grid voltage, then the power flow will be reverse direction. That is, the power flow will be from the AC grid into the DC source, or battery gets charged that one. Therefore, then the role of this converter is equal to a rectifier. Therefore, bidirectional power flow can be done here. When power is flowing from DC source into the AC grid, this is working as an inverter. Then power is flowing from the AC grid into the DC source, this is working as a rectifier. Therefore, this is a grid connected system in which the source, that is maybe the solar PV panel source as DC source, that is connected to the grid after converting through an inverter, and that is connected to the three-phase AC grid through a linking inductors LA, LB, LC. Therefore, by controlling the magnitude and polarity of the voltage injected to the grid, you can control the power flow between the DC source and AC grid. Therefore, this will be working as a bidirectional power flow. You can do that one also. This shows the block diagram of a grid connected solar power system. Actually, PV's array is and PV array. There's a maximum power point tracking plus DC to DC converter. Maybe boost converter or buck boost converter is there. Therefore, that DC available, that one, and that DC, of course, circuit breakers, the protection is there. That DC is converted into AC using an inverter. That is that three-phase AC is generated, and that three-phase AC, of course, in order to link with the inductor, there should be a transformer should be there to match the voltage rating of that one. Therefore, a transformer, delta star transformer is there. Of course, these are circuit breakers are for the protection, and this is connected to the existing three-phase grid. Therefore, this is the block diagram of a grid connected solar power system in which this is a three-phase line and this is a PV system, and in between that one there's a DC to DC converter plus MPPT controller, and there's a DC to AC inverter that is connected through a transformer and to protective circuit breakers, and that is connected to the three-phase AC grid. Therefore, this is a grid connected solar power system. Now, this is also grid connected PV system, but this is only for a single phase. I'm explaining only for a single phase. In that case, as we have seen, this is a solar panel, and the solar panel, of course, there is a converter there's a converter, boost converter. By controlling the duty ratio of this one, you can extract the maximum power or maximum power point tracking can be done by controlling the switch of this boost converter, and so that it can extract the maximum power from the solar panel, and that power is again that is used to charge. That is used, there's a battery is there, of course voltage will be getting that DC voltage again converted using a AC, that is to converted AC using a inverter. There's an inverter, an H-bridge inverter is there, that will be switching such that you will be getting AC output voltage at the output of this one, and that is filtered, and you will be getting a sinusoidal voltage, and that is connected to the single phase grid. Therefore, this is a grid connected PV system for a single phase in which solar panel is there, there's a boost converter is there, of course with a MPPT controller, and there is a inverter, H-bridge inverter is there. By controlling this inverter, these switches, you can have a sinusoidal output here. After filtering you can have a LC filter is there, you can have a sinusoidal output that is connected into the grid. Therefore, the power flow from the AC, from the DC source solar panel into the AC grid can be controlled by controlling the inverter.